Natural disasters are beyond our control, and they cause massive destruction. One such natural disaster is a tsunami. Tsunami is a series of ocean waves with extremely long wavelengths that travel across the ocean at high speed and can be devastating when they reach the shore. So why does a tsunami occur? What causes these giant waves to crash into the shoreline and wreak havoc? The answer lies in understanding the powerful forces that shape our planet and the deep connection between the land, the sea, and the Earth's crust. Join us as we delve into the depths of this phenomenon and explore the hidden causes of tsunami. Before we start, please like the video and subscribe so you will be notified when we upload new videos. A long time ago, even before the birth of human beings on Earth, nature had its own way of balancing itself. This natural balance is sometimes broken by natural calamities like earthquakes, volcanic eruptions, and landslides, which upset this balance. When this happens, it triggers a series of events that causes a tsunami. Tsunamis are most often caused by underwater earthquakes that happen under the ocean floor. These earthquakes typically happen when two tectonic plates that make up the Earth's crust suddenly shift and move past each other along a fault line. When this occurs, a tremendous amount of energy is released, causing a massive displacement of water. This displacement generates a series of waves that radiate outward from the epicenter of the earthquake in all directions. As the waves move away from their source, they gain speed and height until they reach the shore. Tsunamis can also be caused by other underwater disturbances, such as underwater volcanic eruptions, landslides, or the collapse of underwater cliffs. Less commonly, tsunamis can be caused by a meteor impact in the ocean or a large landslide above the ocean that is not caused by an earthquake. In recent times, tsunamis have become more common. According to National Geographic, a tsunami has occurred somewhere in the world once every 24 hours. A majority of them go unnoticed, because they happen in remote areas of the ocean. However, the ones that hit the populated regions can be very dangerous. It was in December 2004 when the world witnessed one of the most destructive tsunamis in recorded history. On that day, a 9.1 magnitude earthquake struck off the coast of Sumatra, Indonesia. The quake triggered a series of devastating tsunami waves that slammed into 14 countries across the Indian Ocean, including Indonesia, Sri Lanka, India, Thailand, and Malaysia. It resulted in a total of 227,898 fatalities, 38,789 injuries, 144,525 missing people, and over 1.4 million displaced people. The tsunami also caused extensive damage to property and infrastructure. In some coastal communities, entire towns were wiped off the map, leaving behind a trail of devastation. Homes, businesses, roads, and public buildings were destroyed, and the economic impact was staggering. Another deadly tsunami occurred in Japan in March 2011, after a 9.0 magnitude earthquake struck off the coast of Tokyo. The earthquake triggered a series of tsunami waves that caused widespread damage along the coastline, leading to the Fukushima Daiichi nuclear disaster and causing approximately 15,894 fatalities, 6,159 injuries, 2,562 missing people, and over 129,000 displaced people. Again, it caused enormous damage to property and infrastructure. The 2004 Indian Ocean tsunami and the 2011 Japan tsunami are among the deadliest and most destructive tsunamis in recorded history. They serve as a stark reminder of the immense power of nature and the importance of preparedness in the face of such disasters. However, there are many other notable tsunamis that have occurred throughout history. In 1498, a tsunami struck the Portuguese city of Lisbon, resulting in catastrophic damage and an estimated death toll of up to 100,000 people. In 1755, a massive tsunami devastated the city of Alexandria in Egypt, killing thousands and destroying much of the city. In 1883, a volcanic eruption in Indonesia triggered a tsunami that killed over 36,000 people in the surrounding area. In 1960, an earthquake in Chile triggered a tsunami that caused widespread damage in Chile, and in 1976, an earthquake in the Nicobar Islands triggered a tsunami that killed hundreds in India and Sri Lanka. These are just a few examples of the many tsunamis that have occurred throughout history. Each one of them serves as a reminder of the importance of tsunami preparedness and the need for early warning systems to protect lives and property. So, what can we do to limit the number of tsunami occurrences? Well, first, we need to understand the underlying causes of tsunami formation. As we mentioned earlier, most tsunamis are caused by underwater earthquakes. These earthquakes occur when tectonic plates that make up the Earth's crust shift and move past each other along fault lines. The energy released during these shifts causes the seafloor to displace, generating a tsunami wave. To mitigate the risk of tsunami formation, we need to monitor and understand the movement of tectonic plates and identify areas that are prone to seismic activity. By doing so, we can develop early warning systems that can alert people in coastal areas of an impending tsunami, giving them time to evacuate. Another cause of tsunami is underwater volcanic eruptions. Volcanic eruptions can displace large amounts of water, creating a tsunami wave. To reduce the risk of tsunami formation due to volcanic eruptions, it's important to monitor volcanic activity and develop early warning systems. This can help people in coastal areas to evacuate and minimize the loss of life and property. Landslides are another major cause of tsunami. Underwater or coastal landslides can displace large amounts of water, creating a tsunami wave. Reducing vegetation on slopes, improving drainage, and implementing erosion control measures can help prevent landslides and reduce the risk of tsunami formation. Additionally, monitoring the stability of slopes in coastal areas can help identify potential hazards and allow for timely evacuations if necessary. We can also reduce the impact of tsunamis by improving building codes and land use planning in coastal areas. Enforcing stricter building codes can help ensure that homes and buildings are constructed to withstand the force of a tsunami wave. Additionally, avoiding development in low-lying coastal areas can help reduce the risk of damage to property and infrastructure. Early warning systems are crucial for mitigating the impact of tsunamis. Developing advanced warning systems that can detect tsunami waves as they approach can give people in coastal areas valuable time to evacuate. This can be achieved through a combination of buoys, sensors, and monitoring systems that can detect changes in sea level and send alerts to local authorities and residents. Education and awareness are also critical for reducing the impact of tsunamis. Educating people about the risks of tsunami and how to respond in the event of an emergency can help save lives and minimize the damage to property. This can be done through public awareness campaigns, school programs, and community outreach efforts. Finally, international cooperation is essential for mitigating the risk of tsunamis. Sharing information about tsunami risks and best practices for preparedness and response can help countries and communities around the world to better protect their citizens. This can be achieved through international agreements, partnerships, and organizations such as the Intergovernmental Oceanographic Commission and the Pacific Tsunami Warning Center. In conclusion, while we cannot completely prevent tsunamis from occurring, we can take steps to reduce their impact and better protect ourselves against these natural disasters. By understanding the underlying causes of tsunami formation and implementing measures to address them, we can create safer and more resilient coastal communities. It is important to note that each tsunami is unique, and there is no one-size-fits-all solution for prevention and mitigation. However, the approaches we discuss in this video can help reduce the risk of tsunami and better protect lives and property. Now let's see what you learned in this video. Question 1. What is the primary cause of tsunami formation? A. Underwater volcanic eruptions. B. Landslides. C. Earthquakes. Question 2. How can we reduce the risk of tsunami formation due to earthquakes? A. Avoid development in low-lying coastal areas. B. Enforce stricter building codes in coastal areas. C. Monitor tectonic plate movements and enforce building codes in coastal areas. Question 3. What is the importance of education and awareness in mitigating the impact of tsunamis? A. It helps people to understand the risks of tsunami and how to respond in an emergency. B. It helps governments to allocate resources for tsunami prevention and mitigation. C. It helps scientists to study the causes of tsunami and develop early warning systems. If you answered question 1, C, question 2, C, and question 3, A, then you get 3 out of 3. Great job. Please remember to like the video and subscribe so you will be notified when we upload new videos. Thank you for watching.